Hello? Hello? Am I live? Am I live? That's a very nice question. I wish I can answer this. I can. I'm live. But what's the name? Oh no. The name is all wrong. Wait a minute. Everything is malfunctioning. This is a nice start to the game engine stream. Doesn't sound very promising. You're gonna wanna give me 1 second. Stream info, okay. Making my game engine. This is gonna be category technology, I guess. What's the... No, what's the categories for game engine? Game engine. Fuck, no. Category on Twitch for coding. It's just called coding, okay. Coding. No, it's not. Google programming, maybe. I mean, we do have just chatting, but that's not it. For coding. Okay, Reddit is gonna be our savior. So, game development category was the center of the game dev community, but they removed it 8 years ago. That can't be right. Game development. There is a game dev studio, but that's just a game engine. Science and tech, okay, that's it. Science and technology, great. Tags are correct, stream language is incorrect. Content classification, politics, no. Drugs, no. Gambling, no. Profanity, well, maybe, but no. Okay, none of this. Okay. And now we're gonna do the same for YouTube if you guys have the patience. I mean, nobody's here, so I guess we can do it. It is in 1080. Stream settings, let's go. Enable DVR, I don't know what that is. I mean, how do I change the stream stuff? Webcam, manage, exit stream. Yeah. Okay. Edit title and description. Okay, the title is gonna be making my own game engine. And then description is gonna be I wanna die. because well, not yet, but it's gonna be a long project and it's gonna be awful. Okay, we are live, we are done with all the stream settings and we can start coding, but first we need to lay out some rules, you know. First of all, well, for now, the only rule I know is that we don't get to use any AI assistant. We have to learn how to do it ourselves. Because AI, well, sometimes it can be very helpful, but knowing me, I would let it do all the stuff and I would just sit and wait, and that's not fun. I don't learn anything from it. So it's gonna be without any AI. And by the way, I have deleted my AI assistant from Google search, so I won't even be having that. I will just have Google, maybe books and stuff, I don't know, but that's it. I think everything I need can be found in Stack Overflow and Reddit and Google in general. So that's what we are gonna be doing. Okay, now to start, I honestly have gone ahead without streaming and I've done some progress. And I know you're like, oh no, I know no coding and this is supposed to be like a tutorial. I don't think so. I can't really do a tutorial for you because I don't know what my shit is yet either. I need to figure this stuff as I go, and you know, you can look at this code and try to figure this out. We will go through it together. Okay. Now, why is everything on a header file? No idea, by the way. Absolutely no idea. This is gonna be moved, but anyway, let's go. So we have the vector.hpp, vector.h, vector.cpp. However, the vector.h is probably gonna go. Everything is in C++, we don't need it. Oh, what? Okay, maybe we will have to fix that one soon. Did I do something? Wait, what? Oh, okay. I did stupid stuff. I pasted some stuff. Okay, let's go. So, we have a class of vector, and this is probably gonna be good to put on a namespace, and let's call this vmath for the vector math. And see, now we've reached our first problem, which is I don't know how to do a namespace. So I'm actually gonna open Brave here, and what I'm gonna do is just search how to do a namespace in CPP. Okay, it just calls it namespace room 1, stuff like that. What's the issue? It's expected the declaration. Oh, because I have the template here. Of course. That was obviously the issue. I wonder if forward declarations can be inside the namespace. They probably can. So we just start everything with the namespace and we end everything with it. That's it. And why did we do that? Why did we make a namespace? Well, The reason is that vector, the word vector, is also in the standard library, and it means a whole different thing. It is just an array, basically, a dynamic array. So we need to call it vector, meaning vector in terms of 3D space or 2D space or n-dimensional space. And because I'm not very creative, I named it the same thing. Well, not only because I'm not that creative, mostly because it's called vector. I like to call it vector. So we put it under this namespace, and now we have a vector class. It has a constructor and another constructor, and these should probably be together, closer together. So this is the default constructor. This is a constructor that it receives some data in terms of a pointer to the beginning of an array, basically. And you can give it the class t and the size n of the vector, and then we get the length calculation, the normalization of the vector. It actually normalizes the vector itself. It doesn't return something, so need to be careful of that. And the indexing operator literally just gives the items inside it, which is nice to have. And then it just has an items array, that's the things inside the vector, and then the length, which is -1, and when we call len, if it's less than 0, it is calculated and returned. Otherwise, it is just returned. That's so that we only calculate length once, and we store it. It's a private variable, so the only way to access length is with len. So that's a nice trick. I don't know. I found it quite smart. Then we have the plus operator overloading of two vectors. It just makes the vector sum, the vector negative sum, and then we have the dot product, which is with the operator of multiplication, and then we overload the operator that basically prints the vector, so that we can print the vector just like this. It's pretty cool because I'm really tired of just std say out and every single index of the vector. That's annoying. So we simply just print the vector this way, and I really like this statement. It basically gives us a comma only when it's not the last element. If it's the last element, it doesn't give us anything. And then this is where it gets interesting, because we need to make, I don't know about like a 5D vector or a one-dimensional vector. It doesn't make sense. I think the vectors that make more sense are the 2D, 3D, and 4D vectors. We make a struct for chords 2D, chords 3D, and then chords 4D. The reason I made this with a union is because, well, it's quite nice to the eye, doesn't hurt at all, and might help us later. I don't know. I just made it with a union. And then I like actually making all this whenever there is an array and then it's like XYZ. I like making it into a union. It's a nice way to just see that, oh look, this has, without saying basically the chords for the instance dot pose dot x, you can just say dot x and it's exactly the same thing. That's why unions are really nice. Now you would say that, oh, why don't you do it with inheritance? Yeah, I mean, why not? We could do that, but then we would have to make it into a class, and that's just a trick to make inheritance before there were even classes. So this is really cool. And then we get a class vector2d. It's just a vector with two variables basically inside. Then we get a constructor for that, default one. We can make it 3D and it just adds a 0. That sounds pretty useful sometimes. Like for example, when we want to have the cross product, and then we overload the equals operator to get the chords 2D. So basically this allows us to do like vec equals, and then, you know, just give it a struct, and it just assigns everything to the vector. So it's really nice. And then obviously a reference to the items index 0 and items index 1, because we don't want a copy, we want this to show exactly the same memory as the items array. Now I won't tire you, that's the same exact thing with vector 3D and the same exact thing with vector 4D. We can delete that note, and then we have like two functions here, a cross product and the dot product. Basically there is no reason to use the dot product function because the operator is overloaded, but it's good to be there, I guess. And the cross product function is basically needed because I was thinking of overloading another operator, but it's not that intuitive, you know, just call a function. That's it for now. That's all I've done. And then I have here a program that should be running, but some stuff, because using namespace vmath. Okay. Yeah. So this program runs, and I'm just gonna build it and run it. So you can see quite clearly, and you can sit and check. These things actually give out correct results, and it's not like I've done too much testing. I'm not gonna lie, but they do seem fine. So you might ask, what are we gonna do today? And the answer is matrices, I guess. I think we're gonna do matrices. So let's make a new file. We're gonna name it matrix.cpp, and then a new file, matrix.h. Oh, sorry, it's an HPP file. Okay, and now let's include, we're probably gonna need CMath, and then I'm gonna need to make a class. And this class is gonna be a matrix, and then the class is gonna be T, and we're gonna get a size T n and the size T m. So the way this works is you're gonna give it what type of matrix gonna be, like double, for example, and then n times m is gonna be the amount of elements it has, rows and columns. So obviously we're gonna need the protected, just like before, items, and then it's gonna be n times m, and the type is gonna be T. So we're gonna have all these items, and what we need is to basically just make the constructor. It's gonna have a default constructor, we need that, and it's gonna have a constructor. Actually, we can't really have a constructor that initializes all elements. We can do it with an assignment. So the default constructor is going to be the only constructor we're going to have, and then we need another class which is the matrix input class, and this has the same templates, and basically the matrix input, interesting. This is really hard to do, actually. See, this is the stuff that once you figure this out, you know how to program well, but I don't. And the issue is that we want to assign the matrix like this. Like, let's say I want a matrix of integers, and then I want to be giving it 0, 1, 2, 3. I want to say the mat, which is the instance of matrix, equals this. But this is a matrix input. So let's make this into a struct, actually, and this has n times m amount of structs. Oh, so wait a second, maybe we can do actually, we are supposing 2D matrices, obviously. So let's make a template class T, size Tm, and that's gonna be struct matrix input in. I'm gonna change the name quite soon. So this is gonna have a type T items of type of amount m, and this is gonna have a matrix input in type T items of amount n, T comma m. I think now that we can initialize a struct like this with the way that I explained it to you. But let's test this. return 0, and then we want to include matrix dot hpp. So let us try to make a matrix input mat in equals, oh, and we want the type to be int, comma, like we're gonna do 3 by 4. So we need 1, 2, 3, 4. And then there's gonna have like boom 3 by 4. I don't know, is this 3 by 4? That's 4 by 3, right? So actually let's just remove this. And I'm just spamming random numbers, doesn't matter at all. So, too many initializer values. Aha. Do you mean to say that this is correct? Because I can do this if you like this better. I guess we can try to compile and see. So matrix.cpp, matrix.hpp, and output is gonna be mat. Too many initializers. Let's do this again. So items n. So we need n brackets, and the brackets are 3, correct. And the brackets must have 4 elements inside, which is also correct. This bracket is correct. Int 3 by 4. Int 4. I'm not sure what I'm saying. Matrix input. Type int 3 by 4. And then this is a matrix input in, correct, of int size 4. And then 3. Okay, shouldn't be 3, it should be 4. So, n times m. So, items n, and then m has to be here. Why is that 3? 3 times 4. Okay, let's do it 3 by 3. If it's 3 by 3, are we having any issue? Clear this. 3 by 3. What's the issue here? Can't I just initialize? Matrix input int 3 by 3. Int 3 and an array of 3 of those, which has a matrix input in of 3, int 3. What's the issue? Too many initializers for matrix input int 3 by 3. We are gonna Google that. let's see what it says. Troubleshooting. No, we don't need PyTorch. Huh. Okay. Doesn't seem like Google was a ton of help. Let me try to understand this. This is a matrix input of size 3. Correct. The issue is view problem. Too many initializers. We have a 3x3 matrix input. Matrix input int of size 3. And this is an array of 3 items. And each one of those Is this correct, maybe? Oh, that's correct. Okay. Now this is not something we want, actually. So there is a redundant parenthesis which doesn't make sense to me. So how do we fix that? I guess we can probably do that, no? Just a t vector of items n times m. And this is gonna be correct now, I believe. I don't see this being too correct. Too many initializers. So this is quite interesting. We can do it like that, which is probably the easiest way, but the initializer needs another bracket. You know, it kinda makes sense. But also not really. Okay. Aha. So the way to do this correctly would be for matrix input to only have size tm, do this, and then Martin is gonna have size of 3, and delete this. I believe now we are correct, right? Yes. So that's fine. So now the thing is, how do I check though? Because I wanna overload the operator, void operator equals, and that's actually not gonna be a void, that's gonna be a matrix, and then it's gonna have an input of a matrix input. Oh yeah, here is where I say n in, and now I just wanna, this does not avoid me the the damn loop, the for loop. Could we use like a mem copy? Is that allowed? Because I don't want to have to have a for loop that goes through every single item for n. Those are literally mem copy does not work because that's on the heap, but those things are really just so close to each other. So I wonder how to copy one array to another in CPP. Yeah, but not array. I don't want to like have an std array. No, I don't want that. Actually, that's fine. We can do this with copy. Copy first array to second array. Ha! Print the second array. Okay, no. No, we don't want that. I don't even know what copy does. std copy. Let's see. Copies the elements in the source range first to last. Copies all elements. Okay. But does it loop through them? Complexity. And assignments and applications of pred. Yeah, we don't use pred. Okay. That's basically what it does. Okay. Do we need it though if it only does that? So when is the matrix initialization happening usually? Usually when loading the game. Yeah. So I'm not sure. I'm just gonna say possible. What is it called? Problem, but I didn't want to say problem anyway, and I'm just gonna do a double for loop. No, I probably should not do that. Well, the thing is, if it knows no. Huh. See, this is the issue when you want to make your code super efficient. Possible inefficiency. Now, what would be a smart way to do this? We have the matrix input. It is just a bunch of items. So we have in.items, index whatever, and those have inside them in index whatever dot items, index whatever. So we're gonna do a double for loop. Make sure it works. I less than n, I plus plus, for int j equals 0, j less than m, j plus plus. Now why not use plus plus j? Probably a better idea. And now items index I index j equals in index I dot items index j. Now items is not a great name for it, but okay. I expected a lot of mistakes, but not that many. Oh yeah, I always do this because I once did Verilog. I once wrote some Verilog and I got used to it. In declared as array of template placeholder. Oh, matrix input of type T, yeah. Yeah, obviously. Now. Oh, it also has a size M. Yeah, of course, of course. Okay, nice. So, now we wanna see if it works. So, I'm getting a matrix A of type double. Actually, let's do int. Type 3 by 3 A equals, and we want to be doing this 0 1 2 3 4 5 6 7 8. Actually, inaccessible. Oh, is it because we didn't make it public? I hate that I have to make it public all the time. Like, come on, it's a constructor. Don't you have the... Oh fuck. Clear. What's the issue? Yes, so what? What is the problem here? No instance of constructor matrix blah blah blah. I wonder, can we just make a constructor for it? Like if we do matrix and it just takes a matrix input of t comma m in of n, can we just copy paste this? Interesting. No instance of constructor. Argument types are blah blah blah. What now? the constructor should simply be the default constructor, no? This one. But also, we can probably do this, no? Three by three. I mean, it should work. Argument types are blah. Yeah, but you should cast this automatically into a matrix input of size 3, no? I guess not. I guess you don't like it. But you have to like it. I'm afraid you don't have a choice. So, what if I just do matrix input in equals this? But the matrix input is obviously of type int 3 by 3. Actually, of type int and 3, and this has a number 3. What if you get this? Now you don't have an issue, right? Aha. You shouldn't have an issue. You don't. But you do have an issue when I put this inside right away. But that's not... Aha. No, that's not the problem. X, V, go. I mean, I don't have a problem just making matrix inputs, but... No, I actually do. It shouldn't work like this. It really shouldn't. So obviously, let me just... Okay. Let me also overload the operator int index and then return. Wait, not a matrix, come on. Return. Actually, yeah. I like that. Oh no. Wait, we can do a vector. And this is gonna be, if we hashtag include vector.hpp, then we will return vmath vector of what? T comma m. Then we return matrix items index n, index actually, but this should be a vmath vector type t comma m, and I think there is an initializer for that. Oh yeah, there is. It's here. It gets okay. Takes the yeah, takes the pointer. However, then res. I think that's correct. So, we have done that. Supposedly, now we can just loop around I less than 3, I plus plus, for int j equals 0, j less than 3, j plus plus. Std out a index I index j std and l, and then std actually no backslash t std out std and l. I actually probably need that. Okay. So, some errors. No matching function to call int3. What do you mean by that? There are 4 candidates. This, no non-conversion for argument 1. Oh, you can't be serious. Int pointer with size 3 to int pointer. Come on. This is quite easy to fix, but I can't think of it right now. Wait. The issue is we are giving a pointer to items index. Yeah. We do need the index 0 here. Supposing it is more than 0, correct? Correct. So let's just run the math. Nice. So now we give 0, 1, 2, 3, 4, 5, 6, 7, 8, and then it prints it. However, I still would like it to not get a matrix input like that. And just be able to do this instead. Just for the sake of usefulness and stuff like that. So either that. Let's try fixing that instead. So I wonder if I cast it to a matrix input of type int, comma 3, does it stop complaining? Why not? I do have this operator, gets a matrix input. Oh. I should cast it to a matrix input object. Yeah. So it can't autocast. That's interesting. It cannot autocast. How to make it autocast? Of course it doesn't work. We need to think of it ourselves. So it does not think that there is a way to do this, but if I just autocast it, let's see. Warning, no return statement in function returning non-void. What do you mean function? Wait, core dumped. Nice. So it doesn't work. Because it does think that's a function. Huh. Oh, because that's the way to do it. Oh. Wait, no, that's not. No, it's not. This is the way you do it. We're not gonna forget all we know. But why does it think it's a function? We are casting it into an array. See, you know, like times like these is when an AI would be very helpful. But I'm not giving in. Index 3. Okay, it does recognize that this is a matrix input of size 3, and then these are it. This is the other one. So, okay, it does recognize it. But why in instantiation of matrix operator equals required from here matrix input 3. Warning, no return statement in function returning non-void. Are we actually... It's returning a matrix. Oh, come on. It should return void. Is that it? Yeah, that's the issue. So, why not be able to do that without the casting? You can autocast. I know you can. But apparently not. Aha, interesting. No instance of constructor matches the argument list. Argument types are these. Okay, so operator. No known conversion for argument 1 to matrix from brace closed initialized list to matrix input int 3. Void operator equals constant expression class matrix. Okay, so we might be able to Google this error because it does make sense. An error that's relevant because aggregate initialization existed all along and did not have a restriction. You should explicitly convert the respective values. Struct x, short I, int init. Okay, you want to static cast, but that's not what I'm saying. The std string has no constructor that takes a single character to use. Single characters in this initialization, you need an initializer list. No, that's not what I'm looking for. What I'm looking for is how to convert argument 1 from brace enclosed initializer list to matrix inputs. Int, 3 pointer. Wait, pointer. Why pointer? Is it because why pointer? Is it because this is a matrix? Shit. Okay. Give me a second, I'm gonna be right back because I need to find something to eat. This is some serious C++ issues here. Actually, it's probably quite easy. I'm just dumb. Be right back. Okay, we are back. We are back and we need to fix this damn thing. But the thing is, for some reason, it's expecting a pointer. Because that's probably correct. I mean, no, come on, it shouldn't be correct. What the hell is this thing? Is it a pointer? Okay. Is this a pointer? No. Okay, okay. No. I guess it can't happen for now. And that's sad. But no need to worry because we can do this. But I really don't want to do this, you know. So this, I think it worked. Yeah, it did work. But I don't want to do this. Why did this work? std out. How can I find this thing's type? In std end line. So this in is a pointer. Yes. And how do I print the type? cpp how to print variable type. Oh, we do have type of. We surely do. Type of or type. Declare type. Type id dot name. Type id of in dot name. Is this function? Yeah. It's a matrix input. That didn't help me a lot. C++ solution. Doesn't sound really nice. Don't like it at all. Very ugly. I mean, this is an issue. It's a problem that I can't find it. Can I do something about it? Like here? You're gonna have to have a matrix input. And this A equals this with double bracket doesn't work. Nope, it doesn't. That's actually lame. Compile. So you can't turn a closed brace and closed initializer list to matrix input int comma 3 pointer. Why? And you can't make it into a const matrix. Candidate 1. This is the correct candidate actually. Const expression, matrix operator equals. Yeah, I know. Here, the operator. With t equals int, long consigned int equals 3. Yes, and m equals 3. No known conversion for argument 1 from braced and closed initializer list to matrix input of type int comma 3 pointer. What if I this is gonna be really stupid, but what if I do this? What now? Huh? If I cast it to matrix input int comma 3 3, now that is correct. So how do I do this without casting? Why does casting work? It does work, doesn't it? It freaking works, but it can't autocast. Expected comma or blah blah. Can I not do this? int can I use brackets? No, int n cpp. No, that's not what I need. No. Yeah, we can do that. It's not freaking Verilog. But this is a whole problem, because now this has to be and I can't make the matrix input be, it has to be somewhere here, like the matrix input has to have a size tn and have an n by m vector, and then here we need n comma m, n comma m. I basically prefer this way more than just not having this functionality, just putting another bracket in. It's fine by me. And then probably this could get a lot more efficient. So I believe, yeah. So here it's just gonna be this, but with an extra bracket. And I think I can live with that. For now, at least. Until I learn a better way to do this. Here, here. So this all works. It's fine. You know, it's just one more bracket. Now the thing is, can we make it more efficient now? I'm in the incorrect file. So here, I'm basically copying with a double for loop. Can't I just say items equals in dot items? How to copy a C vector to another one. A C array, is it called? Yeah. Okay, it's a memcopy. That is nice. Good to know. So we just do memcopy item to in.items. Actually, wait, how does memcopy work? To array 2, array 1. So to item from in.items, and then the size of the array, but that's like n times m times size of that, which is basically pretty easy because size of t. I believe that is correct. So I think that makes it a lot faster. Not really sure though. Fuck. Error. Item was not declared in this scope. Oh, we do have items. So that was a slightly big bug. Memcopy was not declared. Memcopy is in string.stdio probably. stdio.h. Is it in string.h? String.io? String.h? It is actually interesting. So does it work? Is the yeah, it does work. That's crazy. So we can just do a 4x5 matrix, and that's just 4, 5, yeah. So 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 9, 10, 11, 12, 13, 14, and then 15 and up until 20 or 19 actually. Yes, so let's fuck. Wait. Oh, of course. That has to go up until 4, that has to go up until 5. Now, yes, nice. Okay, so we have our matrices, we have a way to create them, we have a way to print them. Now we need a way to multiply them. And that's gonna be interesting. So let's return a matrix. Let's make a template of like a size t, n times m times l, let's say, and then the matrix is gonna have an output on n times l. Operator times, and then we get one matrix. Oh, let's not do this in here actually, let's do this outside. This may make sense outside. So it's class t, size t n, size t m, size t l, and then it returns a matrix of whatever, and then the operator of matrix t comma t comma n comma m mat1, and then the matrix t comma certainly m comma l mat So, the thing is, there are very quick algorithms for multiplying matrices that are not the complexity, whatever complexity O(n) squared, basically. But I don't know them. I think we can assign to the matrix, but let me see. Actually, no, we can't. Um, have we overloaded this operator? We have. That's only for reading, not writing. How do we write? Let's worry about this later. We need to learn how to index our matrix so that we can write in it. That is an interesting question. We could make the items public, but I don't like that. I would like to simply index the matrix itself, but that may not be possible. I believe this should be a set of vectors, vmath vector of type t, m, items n. Yeah. And that's gonna make a whole set of problems. Oh shit. It's gonna be... Oh no. Fuck. This introduces so many problems that I don't want to do that. I would prefer to just make this public. Yeah. Just make this public. Should we just make this public? Matrix index I, that would return a vector. And then a matrix index I index whatever would return a type T. But we can't assign. How do we do the assignment? Overload operator for assignment. Can this happen? overloading the assignment operator. That's not what I want. So how do we do this without a setter? Object index with brackets CPP with, yeah, brackets, not curly braces. Object instance index I equals I. fuck. It would be so much simpler if I spoke to chat GPT. I don't think it's such a big deal, though, to make it public, the elements, I mean. I think we probably should and just get over with this. So, simply go to the matrix, not CPP, HPP, and then just, where is it? Make it public. Then here we have so what do we have here? Let's make the biggest. So how our matrix is multiplied? Let's see. Paint.js. So we have a matrix A, B, C, D, E, F, and then let's say we have a G, H, I, J, K, L. The multiplication gives A times G plus B times I plus C times K. So this is M, this is N, this is N, this is K. This is M, this is K. So for each M, take each row, multiply it by this. So I believe it's O one-third. I less than N, I plus plus I, for int j equals 0, j less than k, L actually, j plus plus, that might be very confusing, for int k equals 0, k less than m, k plus plus. So, for a certain I and j, we are at a certain place. And then for each n, we take this index I, comma k. So it's mat1 index I index k times mat2 index j index k index k index j, sorry. That's the result for our matrix TNL res res dot items index I index j equals this mat1 yes. Actually plus equals because let's just say that we have a clear also that loops I less than n I plus plus loops through everything and clears them m j plus plus j plus plus I items index I index j equals 0. So since we have the clear and it's void clear, we do res.clear. So we basically initialize it to 0 and then we add all this stuff. Then we return res. That's fine. So let's try it out. We have this matrix and then we wanna have another matrix, let's call it B, and then that should be 5 by 1, let's say. So five. So 1, 2, 3, 4, 5. And one element into each of these. Let's go with just 1, 2, 3, 4, 5. And then we want to print, well, let's just create the matrix of int, comma, it's going to be a 4 by 1 matrix. Res equals A times B. And then let's say out the res. Lol. Yeah, because those are all wrong. So j less than 1. Clear. Oh, sorry. Compile, run. 40, 115, 190, 265. So this is kinda tough, but we can do it by hand. It's gonna be awful. No worries, just don't look at my drawing. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I starting with 0? Yes, I am. Go back. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah blah blah. I don't think we need those. 13, 14. I'm gonna do it all. 15, 16, 17, 18, 19. I think that's correct. Yes. And then we multiply it by 1, 2, 3, blah blah blah. So for the first element it's 2 plus 6 plus 12 plus 20, which is equal to 40. Is this correct? It is. And then let's do one more. 5 plus 12 plus 21 plus 32 plus 45. This is equal to this 21. Okay, this is 17 plus 21, 38 plus 32, 70, 80 actually. Oh, actually 70 plus 45, 115. Is that correct? It is. Okay. I'm not checking everything. This is correct. So, this is the stupid way to do it. I believe there are way faster optimized methods for matrix multiplication list. What is it called? Complexity algorithm. There are algorithms for the list complexity. Cache behavior. Actually, I think our cache behavior is quite bad. Where is it? It's right here. So indexing I and J, it's fine. Cache is fine. I and K is also fine, but K and J, that's the problem. And I don't know what to do about that. Divide and conquer algorithm. That is the correct solution, I think. Block partitioning. So that's what we're gonna be doing next time. We're gonna be partitioning the matrix and creating an algorithm that is way faster for multiplication. Doesn't sound really easy. Oh, it also helps with inversion. So we're gonna try to do that. It has to be a block matrix though. So, in fact, why don't we actually just create very quickly a new class which is a block matrix which takes public from a matrix, and this has a template of t comma n, and this matrix has t comma n comma n. Sorry, class t and size tn. So a block matrix is basically just a matrix that has the same element size for its dimension. And oh shit, wait. Oh, okay. No issue. no issue. And then the block matrix initializer starts with just the matrix initializer, I guess. Just calls that. And then we have a block matrix with a matrix input. Block matrix, matrix input. This is what is called, but now we have n, n. I think our constructors are fine. Let us try to make one block matrix. Let's make it int 4 by 4. Actually just 4, yeah. Mat block, and we make this into 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10, 11, 12, 13, 14, 15, 16. Okay. We can't assign it right away, but we can call the constructor. No instance of constructor block matrix t, n matches the argument list. Why? I'm sure the compiler will say. So I probably don't remember how to call constructors. Oh, I actually do. Boom, and then boom. Clear. Try again. Block matrix does not have any field named matrix. Well, how to call parent? What kind of function is that called? From child CPP. Yeah, that's what they do. Oh, never did that. Class block matrix does not have any field named matrix. It shouldn't have any field, brother. It should just call the shit. Does not have any field called matrix. is private within its context. Oh, is that because these are not public? Yeah, most of our errors are gone, but now matrix expressions, class does not have any field named blank. You can't initialize member variables declared in base classes because the base class constructor has already initialized them. Ha ha ha. ZSOL object. I don't know what he's doing. See, this one works well. My inheritance is public. All these shits are public. I need to eat and close the stream. Public. Public. Class block matrix gets a public matrix, and you get a matrix input, block matrix, what's the issue now? Like, does it need a template like n times n? Is that the problem? Really? Is that the issue all along? Like, that's stupid if templates work this way. It's really stupid. Oh my god. Just please let me just run it. Nice. Okay, so now we have a block matrix, and the multiplication of both is gonna be overloaded up here. So this is coming next episode. This episode was a disaster. We only wrote like 77 lines of code, but the thing is, this is gonna be really important. So we need to implement algorithms for it to be as quick and also as readable as possible. So yeah, I will see you in the next episode. Bye. How do I close this?